In this problem, we are given a parabola with the equation y equals to negative x squared plus 2x plus 3. The parabola has a y-intercept a and x-intercepts of negative 1 and 3. We connect the points a, b, and then we have 2 points, p and q. P is a point on parabola, while q is a point on the line AB, such that PQ is perpendicular to AB. When the value of PQ is maximized, what are the coordinates for the point P? So our first instinct to solve this problem might be to apply the formula to get the distance from a point to a line, as that seems like the obvious approach, because we can easily find out the equation of line AB since we are already given the coordinate of one of the points on the line, B. To find the coordinate of the point A, well, we know that the y-intercept is just when x equals to 0, so A will equal to 3. So the equation for AB will just be AB is y equals to negative x plus 3. And then just apply a formula to get the distance of PQ. However, that's not the most optimized approach. If you know a model for this case, you can solve this problem in less than a minute. If you observe this portion of the parabola from A to B, you'll notice that this seems like a bow and arrow model, or in other words, a circular segment. So a circular segment means that if you take a portion of a circle, let's say this is a portion of a circle and you cut it with a secant or chord. Well, in this case, it's a similar scenario, except instead of a circle portion, this is part of a parabola. And what is special about this? Well, the special part of this is that it works in a similar way to a circle, which means that when you want to maximize the length of PQ, where PQ is perpendicular to AB, and also when you want to maximize the area of triangle APB, and also when you want to find out the maximum length of P, and when you want to draw a vertical line through P that is perpendicular to the x-axis, when you want to find the maximum of all three of these cases, well, the point P is going to be corresponding to all three of these cases, meaning that the point P is the same point for all three cases. So, how do you find the coordinate of P? This model states that if we call this as xp, the x-coordinate of P, well, this will equal to the x-coordinate of A plus the x-coordinate of B divided by 2. So in this case, it will equal to, since the coordinates of A is 0, 3, become 0, and then since the coordinates of B is 3, 0, become 3, divided by 2, equals to 3 over 2. So now we have the x-coordinate for P. And then the y-coordinate for P would be equal to, let's plug it into the parabola equation. Yp will equal to the negative of 3 over 2 squared, which is negative 9 over 4, plus 3 plus 3. So it will equal to 15 over 4. So the coordinate of P would become 3 over 2 and 15 over 4. So that is how you solve this problem.